Surabhi, a master teacher of chemistry at Vedantu. Welcome to the one-shot video of chemical bonding. Yes, shall we start? Okay. So what is chemical bonding? It's basically the force which holds the atoms together so that they can form compounds, molecules, for example, hydrogen, nitrogen, oxygen, water, ammonia, HCl. So Joby, we have different categories, right? We have acids, bases, salts. They're all molecules. They're all compounds. So how are they formed? Because of the chemical bonds, right? Yes. So chemical bonding, what is the reason? Because anyway we have 118 elements. So why should they combine, ma'am? Yes, I know that's an important question. So as we already have learned that, you rarely find the elements in their free state or elemental state. That is because they are unstable, right? When we write the electronic configuration, most of the atoms, they do not have 8 electrons in their valence shell. So we all know that only when an atom attains duplet configuration or octet configuration, then only they can be called as stable. So that is the very important reason they undergo this chemical bonding. And the other one is, whenever they form bonds, the energy, obviously it decreases. So one thing we should know, what is the relationship between the stability and energy, is lower the energy, more stable are the compounds or molecules. So to attain the minimum energy level, they tend to form bonds to complete octet or duplet. So once they have that octet or duplet configuration, so duplet in case of hydrogen, lithium, beryllium, so they have the tendency to lose electrons like 1, 2, 3, so that they can attain the um, electronic configuration of helium. So hydrogen, of course, it accepts or it shares electron, whereas lithium and beryllium, so they lose electron. Now, what exactly is this octet rule? The octet rule refers to the tendency of atoms to prefer to have 8 electrons, octatomic, octagon. So it means 8, right? So as we all know, when we already have studied so many chapters, now we have thoda sa knowledge about octet rule. So all the elements, whenever they are combining, they are sharing electrons or the transfer of electrons. Of course, I'll tell you what kind of bonds will be formed and what are the kind of compounds forms. But we all know that whenever they lose electron or gain electron, they will have 8 electrons in their valence shell. So in order to attain that 8 electrons in their valence shell, that is the reason they form bonds, either by sharing of electrons or complete transfer of electrons. 8 electrons is important. So modes of chemical combination. Okay, so this can occur in 2 ways. First one is by complete transference of one or more electron. That is, usually you will see this in metals. है ना? Sodium के पास कितने electrons है? 281. 11 electrons, but in its valence shell it has only 1. So if it loses this 1 electron, bingo, it has 8 electrons in its valence shell, so it can be called as a stable ion. है ना? Or let's take calcium. Okay, 2882 will lose 2 electrons to form Ca2 plus. Now it will have 8 electrons. It will be very much stable. So by complete transfer of electrons, so metals will combine with non-metals. So they will just give the electron, and the others like non-metals like chlorine, fluorine, bromine, so they accept electrons and there will be electrostatic force of attraction between them. Boom, an ionic compound will be formed. By sharing of electrons, covalent compounds, CO2, H2O, HCl, ammonia. There are lots of compounds. So this is formed between non-metals. So what exactly is ionic bonding or electrovalent bonding? When a bond is formed by complete transfer of electrons from one atom to another, it is called as ionic bond or electrovalent bond, because there will be formation of ions, right? So our best example, yes, I am going to talk about NaCl. So Na 281, whereas chlorine has 287 electrons. Now what this sodium atom does it transfers one electron to chlorine. Now sodium has 28, chlorine has 288. This will become positively charged as it has lost one electron, and chlorine will become chloride ion as it has gained one electron. And because of the strong electrostatic force of attraction between them, ionic bond will be formed, and the compounds having ionic bond, they are called as ionic compounds. So generally ionic bonds are formed between metals and non-metals. NaCl, MgO, CaO, KCl, they're all examples of ionic bonding. Okay, so formation of sodium fluoride. See, Na, it has one electron in its valence shell, so it is giving that or transferring that one electron to fluorine atom, which had 7 electrons. So after gaining an electron, so it becomes fluoride ion, and sodium is sodium ion. Now there will be formation of ionic bond. That is how it is done. Okay, so we have spoken about NaCl already. See, it is like Na plus Cl minus. Now this dog had one bone, that is electron. So they fought, but here in the metals case, they willingly transfer the electron in order to attain stability. Now this has no bone, so it is Na plus, and as this one has two bones, it will become Cl minus. That's how it is. Okay. Now coming to the properties of ionic compounds. So they have high boiling and high melting point, because in order to break them apart, as they have strong electrostatic force of attraction between them, we need to supply lots of energy. So that is the reason they do have high melting and boiling point. Second one is ionic compounds form crystals. So the best example of ionic compound is common salt, right? NaCl. So if you go and see, they are present in the form of crystals. Generally, ionic compounds, they exist in the form of crystals. That's the second property. Electrovalent compounds or ionic compounds, both are same. So they dissolve in water, but they are insoluble in solvents like oil, petrol, that is organic solvents. They do not dissolve, but they readily dissolves in the water. Very important. Okay. Next, ionic compounds, they do not conduct electricity only in solid state, but they do conduct electricity in the molten state or in their aqueous state, because I just told you that they will be in the form of crystals, right? So when they are in the form of crystals, the ions are not free. So only when they are added to water or when they are heated, so there will be increase in the kinetic energy, so the ions are free to go, or in case of the aqueous solution, the ions can move forward or in whatever the direction they want because of the medium they have. So this is exactly the reason ionic compounds, they do not conduct electricity in their solid state, but they do in the molten or aqueous solution. Now coming to the Lewis dot structure, which is important. So how do you write it? Okay, so these are the steps which you have to maintain. Follow. Write the chemical symbol of the elements. Represent the valence electrons around the symbols in the form of dot or star. I generally write dots. I do not write stars because this is kind of difficult. And this is easy. To show the transfer of one electron, use half-headed arrow. So this is what is half-headed arrow. Because as I am only transferring one electron, so I'll show the half-headed arrow. So if you are transferring two electrons, then you can show the full-headed arrow. This is full-headed arrow. This is half-headed arrow. Okay. So shall we try writing one? See here, Na. So we are only showing the valence electrons. Okay, you don't have to show the inner shell में जो भी electrons है 2, 8. There is no need. So valence shell or outermost shell में it has one electron. So I'm showing the transfer by writing the one single headed arrow to show that I am transferring one electron. So you will get Na plus and Cl minus 1. So in case of Ca or Mg, so there will be transfer of 2 electrons. Okay, but if you're transferring 2 electrons to the same atom, you can show the full headed arrow. So here in case of magnesium and chlorine, so magnesium is giving one electron to one atom each. Hai. So that is the reason we are showing the single-headed arrow. Okay, clear? See here, Mg 2 plus. So basically it is transferring 2 electrons, so you can actually show the 2 full-headed arrow here. Next, the second mode is by sharing of electrons. Yes. So we have non-metals like carbon, nitrogen and all that who it is kind of difficult for them to accept 3 electrons, or carbon though we have studied in organic chemistry, it is difficult for it to lose or gain 4 electrons, right? In that case, sharing of electrons sounds ideal, and that is how they form compounds. So by sharing of electrons, there are two types: covalent bonding and coordinate bonding. Now what is this covalent bonding? The bond formed between the two atoms by mutual sharing of electrons between them is what is called as covalent bond or covalent linkage. For example, let's take an example of HCl. Okay. So what is the atomic number of hydrogen? 1. That means it has only one electron. I'll write it. And chlorine, it is 287. It has 7 electrons. Now this hydrogen needs one more electron to attain duplet configuration, and chlorine needs one electron to attain the octet configuration. But the problem is hydrogen is not ready to give one electron to chlorine, because again it has to gain 2 electrons. That's very difficult. And chlorine, it already has 7 electrons. One more electron, it will be stable. So they are not ready to transfer electron to the other atom. So what they do is they will decide to share electrons. Okay, I have one. You also donate one electron to the bonding. Now these 2 electrons or one pair of electron belongs to both the atoms. So this is also stable. If I have to write chlorine 1, 2, 3, 4, 5, 6, 7, 8. This is also stable. So this is how a covalent bond is formed, by sharing of electrons. H2, Cl2, N2, O2, F2, HCl, NH3, water. So ionic compounds is formed between a metal and a non-metal, whereas covalent bonding, so usually between two non-metals. Okay, metals generally they do not form covalent bonding because they're always ready to give electrons, take, because electropositive, right? Metals are electropositive in nature. Okay, so this is how a hydrogen molecule is formed, by the formation of a covalent bond, and here one bond means one pair of electron. See here, the dog, it had one bone, but they just fought and now they have 2. So these 2 bones belong to both the dogs now. Yay! So it is always better, right? Instead of having 1, now they have 2 because they are sharing it. So that is what is the meaning of covalent bonding. Okay. Some important points: the atoms of the non-metals 5, 6 or 7 electrons in their outermost shell. So except carbon, which has 4 electrons, and hydrogen, which has 1 electron in their outermost shell, they form the covalent bonding. Now coming to the types of covalent bond, you have single covalent bond. So there will be sharing of only one pair of electron, that is 2 electrons. So सिर्फ एक ही bond होगा. Next is double, right? Then there will be sharing of 2 pairs of electrons and there will be formation of a double bond. So what are the examples of single covalent bond? HH, Cl, FF, NN. So they all form the single covalent bond, right? Now coming to the even, so like if you look at the methane here, we might see there are 4 bonds, but between carbon and one hydrogen atom there is only one bond. So this will be considered as single covalent bond. I have seen students getting confused, like, hey, oh, there is 4 bonds, huh? Tetra. No. So generally you don't find tetra bond. So this is also single covalent bond. Next is double covalent bond. So when there is sharing of 2 pairs of electrons, for example, we have oxygen, right? What is its electronic configuration? 2626. So they both need 2 electrons. So they will share 2 pairs of electrons and there will be formation of a double covalent bond. Okay, see, oxygen. So these are the electrons that are shared. 2 pair of electrons, that is 2 bond, that is what is called as double covalent bond. Or even in case of carbon dioxide, the structure is linear. See, carbon and hydrogen के बीच में double bond है. That means, so between carbon and oxygen, there is sharing of 2 pairs of electrons or 4 electrons. The last one is triple covalent bonding. So when there is this sharing of 3 pairs of electrons takes place between the atoms, that is when triple covalent bond is formed. Can you give me an example? Nitrogen, very good. HCl, yes. Nitrogen, triple bond, even in between carbon and nitrogen, there will be a triple bond. So these are the few examples of compounds having triple covalent bond. Yes, nitrogen molecule, even HCl. So that is also an example. Or we have alkynes, right? Propyne, ethane, they all contain carbon-carbon triple bond. Next is, what is this electronegativity? The tendency to attract the shared pair of electrons. Okay, firstly they have shared electrons, very good, they both are stable. But there are atoms who are very greedy, they are very greedy. They're like, I want these shared pair of electrons. So for example, in case of HCl, hydrogen has also given 1 electron for the formation of bond. Chlorine has also given 1 electron. So ideally there should be the shared pair of electrons should be between them. But this chlorine pulls the shared pair of electrons towards itself. So this is what is known as electronegativity. The tendency to attract the shared pair of electrons towards itself is what is known as electronegativity. If you look at it, of course, the fluorine will have the highest electronegativity. We have hydrogen, carbon, nitrogen, chlorine, oxygen, fluorine. So if you have a difference in the electronegativity, when we are talking about Cl2, so Cl का electronegativity same ही है So the shared pair of electron will be between the 2 atoms. But when you have hydrogen and chlorine, so hydrogen ka electronegativity is 2.2, whereas chlorine is 3.2. So the 3.2, this is more electronegative. So it just pulls the shared pair of electron towards itself, and that is when polar covalent bond is formed. Now what exactly is this polar covalent bond? When 2 atoms of different electronegativity form covalent bond, so that type of bond is called as polar covalent bond. For example, non-polar covalent bond, almost same type of atoms, that is Cl2, N2, O2, right? There is no difference in the electronegativity. But when there is difference in the electronegativity, what happens? The compounds, they tend to pull the electron pair towards itself, right? That is when there will be polarity induced. So that is when we write delta negative and delta positive charge. So that exactly is the reason. If you remember, when we talk about the properties of covalent compounds, we always say they are poor conductors of electricity. But in the acids basis chapter or in the chemical reactions and equations, we see HCl, H plus Cl minus, it's an acid. How? It is because it is a polar covalent bond. So here what happens? So this is hydrogen, this is fluorine. So if you see, both have 2 electrons, but look at this share. Almost 75% of that bone, it's in this dog's. Is it a dog or a fox? Fox mouth. So that is what is polar covalent bond. So as they are pulling that electrons towards themselves, so there will be a slight negative charge on them. Some other examples, water molecule. Yes, water is polar because hydrogen and oxygen के बीच में there is electronegativity difference. Ammonia molecule, hydrogen fluoride, hydrogen chloride. Yes. Next is when 2 atoms of same electronegativities form covalent bond. So those kind of compounds, they are called as non-polar covalent compounds, and the bond is non-polar covalent bond. H2Cl2 N2O2. Yes. Now, what are the conditions that an atom should follow if it has to form a covalent bond? So, both the atoms should have high electronegativity. Both the atoms should have high electron affinity. So, if we already have studied about the periodic properties, if you think about it, left side of the periodic table may the electronegativity, electron affinity, everything is less. So, that is the reason metals cannot form covalent bonds. Both the atoms should have high ionization energy. We all know this, right? All the three increases across the period. So non-metals may electron negativity, electron affinity, ionization energy, everything will be high. So that is the reason they form covalent bonds. So what are the properties of covalent compounds? They are volatile. I mean, they will have very low melting and boiling point. So because even though covalent bond is a strong bond, okay, I am not saying no, I'm not denying that, but still the amount of energy required to break that is not like you don't need large amount of energy. So that is the reason there will be weak intermolecular force of attraction between them. So it is easy to break them by supplying very less amount of heat energy. So these are like generally the ionic compounds are crystalline solids, right? But the covalent compounds, you will find them as gas, liquids, and soft solids. They won't be hard solids, they will be soft solids. Water, yes, we have chlorine, which is a gas. Of course, they are non-conductors or poor conductors of electricity in their solid, molten, or aqueous state due to the absence of free ends. So what happens here is, in case of ionic compounds, when they are transferring electron, so one atom will lose electrons, the other will gain electrons, so there will be change in the number of protons and electrons, so that will attain some charge. But in case of covalent bonds, as there is sharing of electrons, there is no formation of charged particles, no free ions, so they do not conduct electricity. Solubility, they do not dissolve in water, but they readily dissolve in the organic solvents or non-polar solvents like oil or carbon tetrachloride, like that. Important point. Some polar covalent compounds ionize in their solutions and can act as an electrolyte. See, that is what I said when we were talking about HCl. Even though it is a covalent compound, despite being a covalent compound, as it is polar in nature, so it does undergo ionization and form ions and conduct electricity. Yay, very good. So what type of bond is in the following? NH4 plus. We all know ammonia तो covalent compound है. But NH4 plus, one nitrogen atom can form 3 bonds, right? So NH, H, H. Then how come this hydrogen? So what happens here is, so this nitrogen which has a lone pair of electrons, so these electrons are there, no? So basically हमारा nitrogen का atomic number क्या है जी? हाँ, 2, 5, right? So now it has formed 3 bonds, but those 2 electrons थे ने, so we are not talking about the inner shell, no. So 5 electrons में 3 are involved in bonding. There are other 2 electrons. So they are called as lone pair of electrons which are not taking part in a reaction. So that those electron pair will be donated. That means there is a formation of bond between hydrogen and nitrogen, but nitrogen provides both the electrons for the bond formation, and such bonds, they are called as coordinate bond. Hydronium ion, same, because water, oxygen, hydrogen, दो bonds हो गया, they are stable. They both, oxygen has octet configuration, hydrogen have duplet configuration, but it has 2 lone pair of electrons, so it will donate 1 pair and form hydronium ion. So what is the type of bond that is formed? So it is called as coordinate bond. Coordinate covalent bond. It is also known as dative bond. So this is what you have to know about the coordinate covalent bonding. So ozone is also an example because we all know O2 molecule is stable, right? But how is it forming one more bond? Not three bonds on oxygen? No. But it does share or donate its lone pair of electron and form the coordinate covalent bonding. So what are the conditions required for the formation of coordinate covalent bond? So they must have at least one lone pair of electron. See, there are cases in which the nonmetals or atoms, they won't have lone pair of electrons and they cannot form coordinate covalent bond. In case of chlorine, bicharite had 7 electrons. So you don't see chlorine forming coordinate bonds. So another atom should be short of at least one lone pair of electron, right? It should not have any electrons. So when I don't have pen, I will go and ask you, do you have an extra one? So as you have extra pen which you are not using, you will give it to me. The same thing. So the one atom has one extra lone pair of electron or at least one lone pair of electron. The other atom, it is short of at least one lone pair of electron. That is when covalent bonding is formed. So Lewis structure of NH4 plus. So we actually use this arrow mark to denote the or to show the formation of coordinate bond. See here also, okay? This arrow mark that represent that, okay, that is a coordinate covalent bond. So this is it. In this session, we completed chemical bonding in one shot. So thank you so much for watching, and do not forget to hit the like button, share this video with your friends, and subscribe to the channel if you are for the first time, and click on the bell icon. And you all know, because of it is a festive season, so we have some nice offers going on. So if you are willing to buy the pro subscription now, you will be getting 50% offer. So why am I saying so? You will get to attend unlimited live classes with fun and high level quizzes. There you will be competing with the students all over the world. You will get the handwritten notes of the master teacher, and assignments will be shared with you. Tests will be conducted with you. Test will be conducted, and what else? In class doubt solving will be there. That is it, people. And this is so, how can I forget this? Free micro courses and crash courses. Micro courses, I have already told you n number of times, they are really good. And once you have taken the pro subscription, these crash courses or micro courses are free for you. You don't have to pay for it. Less is more, that is higher the number of sessions you attend or to take, that is 3 months subscription, you need to pay less. So that is 50% offer up to 2000 rupees. It's only till 21st, so grab the offer now. See, till 21st June academic year 2020-21 plan, so you will be saving. So one session ka price hoga only 5.83 rupees. Oh, so this is almost like 5 rupees wala less. You know, instead of 10 rupees one, I'll put 5 rupees one. Okay, so do not forget to subscribe to the channel and hit the like button. Thank you so much. We are done with chemical bonding in one shot. I'll see you in the next session. Bye bye. Take care.